bank, there's a personal identity number which is called a PIN, which consists of 5 digits chosen from the digits 0 to 9. How many personal identity numbers are possible if the digits may be repeated, if the digits may not be repeated? Now the question is, how many digits are there? 10. There are 10, not 9. Okay, you are including the 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Right? So if repetition is allowed, it means if you want a 5 digit PIN, you're going to have this scenario. Right? The first position can be occupied by all 10. Since repetition is allowed, the second by all 10, third by all 10, fourth by all 10, and the last one by all 10. And then you apply the fundamental counting principle. So, how many pins? So, number of pins. This will be equal to 10 to the power of 5, which is 100,000. Okay. Then the second one, the number of pins when digits may not be repeated. We're going to have this scenario. So the first position can be occupied by all 10. Right? Now, repetition is not allowed. So if you put a digit here, you can't put it there. So you have 9 here, then 8, 7, then 6. Then you apply the fundamental counting principle. Right? Now you can just multiply 10 times 9, 8, 7, and 6. Right? So the number of pins will be equal to 10 times 9 times 8 times 7 times 6. What answer do you get? 13,000? 30,240. So you can do it this way. Or you can use the function on a calculator, which will be 10 choose 5. Right? If you put that in your calculator, you do that. Try it out. 10 choose 5. Yeah. It will give you 30,240. Okay. So you can decide which way. Yes? It's not like choose, but it's the function that I told you yesterday, LPR. This one is choose. So 10 Are you following? Okay. Then let's do this one. Right. The question says, consider the word counted. Right? How many ways can the letters of the word be arranged if each letter must be used exactly once? Right? So if repetition, okay, if each letter must be used only once, means no repetition is allowed. Right? So we have got 7 letters. So 1, 2, 3, 4, 5, 6, 7. Right? Repetition is not allowed. It means the first position, all 7 letters can take it. Then 6, 5, 4, 3, 2, 1. Then use the fundamental counting principle. Now, it's much easier. I'm sure you can see that this one we are starting from 7 all the way up to 1. Therefore, we can use the factorial. Okay? So, number of ways. Number of ways, it will be equal to 7 factorial. And this will give you 5,040 ways. Okay? The reason why I'm using the factorial directly because I'm multiplying the digits from a very large value all the way up to 1. Okay? Then, the second one, How many 5-letter words can be formed from the letters of the word counted if no letter may be used more than once? So from the same 7 letters, we want to make a 5-letter word. 1, 2, 3, 4, 5. The first position, all 7 can take it. Then 6, since repetition is not allowed. Then 5, then 4, then 3. Then use the fundamental counting principle, right? So here, the number of ways will be equal to 7 times 6 times 5 times 4 times 3. And what is the answer? 2,520. Or you can also say 7 choose 5. You should get that as well. You've got 7 letters, but you're only choosing 5. Yes. Okay, for this one here, it will be 7, choose 7. Okay. Can you check for me what is 0 factorial? 1. So for the first case, if you want to use the permutation function on a calculator, it will be 7, choose 7. Because you want all the 7, you want to make a 7-letter word. But you have got 7 what? Letters. So if you 7, choose 7, it gives you the same answer as 5,040. Okay? Are you following? Okay, don't leave 7, choose 7, just put 7 factorial. If you can't understand that. Right? Just do it the way that I just did. Let's not complicate things for the first one. 7 factorial, then we are done. Alright? Now, sometimes you can have restrictions. Okay? Sometimes you can arrange objects. Now, this is today's lesson. I'm starting from here now. Alright? When you are doing questions on the counting principle, there are times when you can have restrictions. Now, the restrictions are of 2 types. Okay? The first ones are restrictions involving positions of objects. Okay? You can also have restrictions involving grouping objects together. So you can have restriction on the position of an object, or you can have restrictions on groups of objects. Right? Like example, I can say, in how many ways can these 3 sit? You see, 1, 2, 3, these 3, they sit in front. In how many ways can they sit in such a way that all the time, Tawalda and Ashel are next to each other? Right? Right? That's a restriction. What that means is he cannot be between them. Okay? He cannot be between them. He can either be to the left of Ashel, like in this case, or he can be to the right of Tawalda. But these two are supposed to be next to each other. But also, he can be to the right of Ashel, and Ashel can be to his right. So we have to consider all those what? Possibilities. Right? Now, with this part now, things get a little bit complex. Okay? Things get a little bit complex when you have got restrictions on positions and restrictions on groups. Let me stop that. Alright, so let's do an example on that. Let's start with that. So the question says, consider the word chemistry, which was one of my favorite subjects when I was in high school. Right? How many ways can the letters of the word be arranged? How many ways can the letters of the word be arranged? So A1, we have got 10 letters there. So the question says, how many ways can the letters of the word be arranged? Alright? Now, these letters here, they can be arranged. Now, in this case, we don't have a restriction where. Okay, it's 9. Alright, so there are 9 of them. We want to rearrange them for this question here. It's not entirely right for them to say to arrange them in what way. We are going to consider the fact that there is no repetition. Okay? Yeah, there is no what? Repetition of a letter. If we are going to arrange them without any repetition, 6, 7, 8, 9, it means the first position can be taken by all 9. The second it will be 8, then 7, 6, 5, 4, 3, 2, 1, which is the same as 9 what? Victoria. Right? So, number of ways will be equal to 9 Victoria. 362,830 ways. 362,080. 880. Okay. All right. So that would be the answer. Then, or if one gets 929, but some names have said 929. All right. Number 2, how many arrangements can be made starting with C and ending with a Y? Now we have got a restriction on position now. So the second part now, the restriction will be the first position must have a C. So that we have got one C there. So this position only has a C, which is 1. Right? So 2, 3, 4, 5, 6, 7, 8, 9. The last one must have a Y, which is also 1. Right? So when you are doing questions on restriction, you must fix what's being restricted first. Then the second position, after fixing the first letter and the last letter, how many letters are left?
7.
There are 7. So this position, all 7, they take it. Then 6, 5, 4, 3, 2, 1. Then use the fundamental counting principle. Now, to use the fundamental counting principle, so I'll say number of arrangements. Okay, I can say 1 times 7 factorial times 1. Okay, remember from here up to there, that's 7 factorial, which is 5040. So we can get 5040 arrangements. Are you following? Yes. Then number 3 says, how many arrangements can be made if the letters M, I, okay, and S must be grouped together in any order? Now this one becomes more complex now. We want M, I, and S to be together. But among them, they can also swap around. Okay? So let me do number 3 on the next page. Is there anybody going to raise any question? Huh? So number 3, this is what's going to happen. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Let's fix the M, the I, and the S. So the question says M, I, and S must be grouped together. Let's say if I start with M here, then I there, and then S, right? I have to consider those 3 as one unit because they are a group. So I will represent their group with a circle, right? Then, once I have fixed those letters, right, how many letters can take the 4th position out of the 9?
5.
6. So we can have 6 here, then 5, then 4, then 3, right? Then we've got 2. Let me just check 6, 4, 5, 6, 7, 8, 9. Suppose put the 9th one. And then we can have what? 1. Right? Now, those 3 we treat them as a group, right? Then this one obviously is on its own, that's on its own, that's one, that's also on its own, and so on. Right. How many circles are we going to have in total? Seven. Seven. Right? The seventh one, it is a group. So we are saying if they are going to switch their positions, the M, the I, and S must be together. They must always be next to what? To each other. But do you agree with me that among themselves, they can also swap? You can have I here, you can have S there, M there, you can have M here, and so on. Right? So the number of ways, now this one becomes a little bit tricky. So the number of arrangements will be equal to, let's start with the circles. How many of them? Seven. So it will be 7 factorial times, right? These three, the M and the IS, they can also swap around among themselves. So that will be times 3 factorial. To read? 30,200. Okay. I hope that you saw what I did there. So the group you treat as one, but within that group there can also be a rearrangement. Okay? Right, let's move on to another type of a question. Right, let's do this one now. It's about people now. Right? So 3 boys and 3 girls are to be seated in the front row at an assembly. Right? The first one, C1. How many different ways can these 6 learners be seated? Right? So we have 3 boys, 3 girls. For now, we don't worry about the gender. Okay? They can sit in any order. Okay, because that's what the first is. So we have got 1, 2, 3, 4, 5, 6. So be aware that you can have any one of the 6 here, right? Then once the person sits there, someone can sit there. There will be 5 left, then 4, 3, 2, and then 1. Right? These are people. People cannot sit at 2 different seats at the same time. So no repetition. Right? So number of ways will be equal to 6 factorial, which is 720. Okay? And then number 2, how many different ways can they be seated if 2 particular learners must be seated together? Okay? So what we are saying is we don't know which 2 here, whether it's a boy or it's a girl. But there are 2 what? There are definitely 2 who are supposed to sit together all the time. So you have 1, 2, 3, 4, 5, 6. Right? It's not about whether they are a boy or a girl. So let's do it this way. So if someone is going to sit, let me call the person, say X. Okay, let me use X here. Then 1. Right? They are 2 different, but they are supposed to do what? Together all the time. Right? Then it means this position, how many can take? The third position? 4. That's 1, 3. This one, 2. That's 1. Right? But among these 2, they can also swap. Because as long as they are together, it's fine. Okay? So the number of ways will be equal to, let's start with the 4, 3, 2, 1, that's 4 factorial times. Now this one here, it will be 2 factorial. Because they can swap among themselves. What answer do we get? Huh? 28. 28. 48. Okay. Then number 3 says, how many different ways can they be seated if all the boys must be seated together and all the girls must be seated together? Now, this one now is going to be more specific. Okay? It's going to be more specific. Right? So, for number 3 now, we are saying the boys are together, the girls are together. Right? So, this is what's going to happen. Let me move on to the next page. So, we have 6 positions. So, you can have a boy here, then it's called boy number 1, then boy number 2, boy number 3. Girl number 1, girl number 2, girl number 3. But the boys are supposed to be together, the girls are supposed to be together. Right? So the number of ways it's gonna be what? How many cycles do we have? How many groupings do we have? So it's 2 factorial first times 3 factorial, not 3. 3 factorial because they can arrange among themselves. So it will be 3 factorial times another 3 factorial.
Times 2.
The 2 is 2 factorial times 2. Huh? Are you following?
Yes.
You are getting 72.
Yeah.
All right. Are you following? Huh? All right. Hey, can you stop that? Right, then the last one says, how many different ways can they be seated if they have to alternate between boys and girls? So you're going to have a boy, a girl, boy, a girl, boy, a girl. You can also start with a girl and then a boy and so on. Right? So you have a number of ways that they can alternate. Right? So number 4, I'm going to have 1, 2, 3, 4, 5, 6. So we can have a boy, a girl, a boy, a girl, a boy, and then a girl. You agree with me there? Then another case would be a girl, a boy, a girl, a boy, a girl, and then you can have a boy. Okay? So these are the so the question will be if they are gonna alternate, how many ways are they?
So that's
Alright. If we start, listen, if we start with the first one. Remember, if they are gonna alternate, right? It means a boy and a boy cannot be next to each other.
Yeah.
Right? A boy and a boy cannot be next to each other. So this boy can sit here, right? This boy can also go there. Right? At the same time, this girl can also sit here and then they can alternate among themselves. So we can't use 6 there. Right? So it will be 3. So we'll say number of ways. Right? Now, you see, if they alternate, you see, if they alternate, right, if we are talking about the swapping of the positions of the girls and boys. But a boy and a boy cannot what? Cannot switch. So in that case, the number of ways will be what? We start with 3 factorial, right? 3 factorial. By 3 factorial, we are saying let's say these boys here, they can swap around among themselves. You agree with me? And the girls can also what? Can also swap around. So it will be 3 factorial times what? 3 factorial. Right? So they can swap among themselves. Right? Then we can have plus. This is another scenario here, where you start with a girl first. So we can have here plus. Right? Again, you can have 3 girls and then the 3 boys. Are you following that? Huh? So this will give you what? 72. Now, this can also be written as 2 times 3 factorial times 3 factorial. Because this gives you the same answer as that. But because I'm teaching here, I have to write it that way so that you can understand it better. Are you following? Okay. Right. I think, can I have your attention? We need to make explanation here. Right? You see, it's not supposed to be 4, it's supposed to be 5. Okay, the main reason is because, you see, we treat each of these as a unit. Oh, fine. This one here, that's 9. We're supposed to put 5 here. Can you make that change?
So how is it 5?
Okay, it's okay. Okay, listen. If you look at the saying, how many different ways can they be seen if 2 particular learners must be together? So these 2, alright, it is very simple. These 2 kids that they are supposed to be together, right? Always they're supposed to be together. Then how many will be left? 4. So it will be 1, 2, 3, 4. But when these 2 swap around, they swap as a unit, as 1. So how many circles do we have? 5. So they're supposed to be 5 here. So this is supposed to be 5 factorial, and change this. Please change that. So this will be 240. Okay. Are you following this? Right. Let's get on to the current question. Have you done that?
Yeah.
Right. So F says a band is planning a concert tour. Unfortunately, it can't happen now. With one performance in each of the cities: Joburg, Victoria, Durban, Bloemfontein, Cape Town, and Port Elizabeth. So, how many cities do we have there?
6.
6. Right? How many different ways can they arrange their itinerary if, 1, there are no restrictions? Right? Which means you can start with any city. Right? So, F1, right? If you start with any city, it means you have got 6 cities. Okay? So you can start with any of the 6 here. Then obviously you'll be left with what? 5, then 4, 3, 2, 1. Alright? So it says how many different ways? So number of ways, it will be 6 factorial, which is 720. Did you get that?
Yes.
Then the next one, can I have your attention? The first performance must be Johannesburg and the last performance must be Cape Town. Now, this one here we have a restriction. So we fix the first position and the last one. So here you're supposed to have Joburg, which is 1, and here you're supposed to have Cape Town, which is 1. So the other 4 cities can take that, then 3, 2, 1. So number of ways, it will become 1, okay, times 4 factorial times 1. 24. What is 4 factorial? 24. So it will be 24. Right? But please be aware, be aware that this position is fixed for Joburg and that one is fixed for Cape Town. So there's only one Joburg, there's one Cape Town. Alright? Okay? Are you following that? Then the third question says the performances of so the performances in the 9 coastal cities. Now this one requires you to know your geography. And Johannesburg, Victoria, and Bloemfontein must be grouped together. So those 3 must be together, right? So we have 6 positions, right? Let's say we have Joburg, then we have Bloemfontein, we have Victoria. This is 1 unit. Then how many are left here? You are going to end up having 3. Can you take that position 2 and then 1? But you take this as a unit because they can also swap around. So the number of ways it will be equal to 4 factorial times 3 factorial. Because the non-coastal cities is 1 unit. You understand? They're supposed to, their order must be close to each other. Can I have your attention? If you start by going to Joburg, you can't go to Durban. Durban is a coastal city, Joburg is not. So if you start with Joburg, you have to go to Bloemfontein or you have to go to what? To Pretoria. If you start with Durban, you can't go to Cape Town. It's a coastal city. So these 3 are always what? Together. But among themselves, you can also start with any one of the 3. That's why you have that 3 factorial. 124.